Okay, this video is for the starred problems for rational expressions and equations. We're going to get into a little bit of solving quadratics, even though we've not actually done that yet, but not anything too complicated. They'll be able to be factored just because they're part of the rational expression or equation. But anyways, so we'll have a little bit of an introduction to that as well. So for this first part, you want to find the domain, and so the domain is anything that, usually it's going to be all real numbers except whatever x or whatever your variable is cannot be. So if we have a rational expression, which is just a fraction, then our numerator can be 0, but our denominator cannot be 0. So the numerator doesn't matter. If it's 0, it's fine, but we just don't want the denominator to be 0. So what we want to do is set the denominator equal to 0 and solve. And usually I write this can't be 0, which is fine if you want to write it with an equal to or not equal to. And you can solve this two ways. You can add 9 to both sides and take the square root, but make sure you do plus or minus if you want to do it that way. I usually factor only because we're going to have to factor on other ones. So this is a difference of squares. And if you have a product that's equal to 0, then at least one of those things would have to be equal to 0. So we would have x is either 3 or negative 3. And like I said, if you want to write it with not equal to, that's fine. But anyways, so if you solve using the square root, you'd have x squared equals 9, and then you take the square root of both sides plus or minus. Square root of 9 is also plus or minus 3. So you get the same answer. I only factored because you're going to want to factor on some of these. So the domain, I'm just going to write D. And you can write this in interval notation or set notation or whatever notation you want. I'm not that picky because I'm just going to write all real numbers except plus or minus 3. You can also write that if you want. If you prefer to write it in some sort of notation, that's fine. If you just want to write all real numbers except whatever you have, then that's fine. So that one's number 2. Number 3 is 3b plus 1 over b times b minus 4 times b plus 5. So for this one, again, the numerator can be 0. We just don't want the denominator to be 0. So we don't have to worry about the numerator. The denominator is already factored. So we set the denominator equal to 0 or not equal to 0 and solve. So we have, again, if you have things multiplied together to give you 0, at least one of those would have to be 0. So you'd have either b is equal to 0, b minus 4 is equal to 0, or b plus 5 would be equal to 0. So this one is done. This one we add 4 to get 4. This one we subtract 5 to get negative 5. And again, we mean that b cannot equal any of those, because if b is 0, 4, or negative 5, we get 0 in the denominator, which is not okay. So this domain would be all real numbers except, I'm going to put them in order, negative 5, 0, and 4. So any other number will be fine to use. We just can't have negative 5, 0, or 4. So again, on those, you're just wanting to know for domain for these, you just want to know where the denominator is 0. Now you can get more complicated if you have a radical, like for instance, if it had the square root in the numerator, square root can't be negative. So but we've not done that yet. So this is just worried about where the denominator is 0. So for the next part, you want to reduce to lowest terms. So number 7 here, we have 16a squared b cubed over 2ab squared. So you just want to reduce this. So you can divide your numbers just like normal. And some of these, most of these I marked out on the paper. I didn't mark this one out, but I'll do it on this. So 16 divided by 2 is 8. If you want to mark it out, you can, or if you just want to write it down over here, that's fine too. If you have a squared divided by a, you subtract the exponents, so the 2 becomes a 1, so you'd have an a to the first, or just a left. And a b squared divided by b, the 3 minus 2 is 1, so you'd have b to the first, or just b left. So if you want to mark out, if that helps you, that's fine. If you just do it in your head, that's fine too. So this is just dividing, just following your exponent rules. And then, of course, dividing your numbers like normal. So for this one, you have 6x squared y to the 5th times x minus 1 times x plus 4 over negative 2xy times x plus 4. So again, if you want to divide and reduce this, then x plus 4 divided by x plus 4 is 1. They just go away, basically. Oh, and I forgot to mention that for all of these, you can just assume that the domain is not 0. You don't necessarily have to write down, you know, x, or like on this one, a can't be 0 and b can't be 0, or this one, x cannot equal negative 4 or 0, or y can't be 0. We're just going to assume that the domain's not 0, so you don't have to say that every time. The only time you need to worry about it is if it actually tells you to find the domain. But anyway, so x plus 4 divided by x plus 4 is 1, so those cancel. 6 divided by negative 2 is negative 3. Again, if you want to cross out and write down, that's fine. X squared divided by x, so you're just putting basically like things together here. So x, 2 minus 1 is 1, so you've got an x left. You've got a y to the 5th and a y. So 5 minus 1 is 4, so we've got a y to the 4th. And then the x minus 1 just stays. And you do not have to multiply that out or anything. You can just leave it written as is. And our denominator is now gone. Everything's crossed out, so it's just a 1 in the denominator, which we don't have to worry about writing. For number 10, you have x squared plus 9x plus 14 over x squared plus 7x. So for this one, do not try to go x squared. I'm going to do it with this pen so that we can see it's wrong. That's not true. The only time you can cross out, the reason I can cross these out is because it's products. So x plus 4 times all this stuff, and then x plus 4 times this, you can cross out. You can't cross out when you have addition, so don't do that. What you want to do is, if you have it like this, you want to factor it. So we're going to factor whatever you can factor. So this factors into x plus 7 times x plus 2 over, in the bottom we can factor out an x, and that's all you can do. So you want to factor first. So don't try to cross out this way. That doesn't work because it's an addition. It's not a multiplication. It only works when you're multiplying. So now over here, I'm multiplying. This is a product. This is a product. Now I can cross out. So I can do this. That's totally fine because it's a product. So I'm left with x plus 2 over x. And that's your answer. Don't try to cancel out these x's because they don't. This is x plus 2. It's not the same as just x. So, so this, like I said, don't do that. That's usually the biggest mistake, is somebody just tries to cancel it out, but you can only cancel them out if it's a product, not when it's adding and subtracting. Okay, so for this section, you're going to need to go back to factoring. Where we've been factoring before, so you have to still be able to do that. You have to factor, and then you can reduce. Okay, so for the next one, we're going to do number 12, which is just a little bit different. So there's two ways to do this one. So like I said, you can't just cross out a cubed and a to the sixth and be done. There's two ways to do it. So on the notes, I wrote it this way, and I'm going to show you another way too, just so you can see. So you can do this. You can split it into two pieces, because if you have this sum or difference, this one's a difference, but if you have this divided by something, then each piece gets divided by that, just like with normal fractions. And then you can reduce that. So a to the sixth divided by a cubed. 6 minus 3 is 3, so we've got a cubed. A to the fourth minus a cubed. 4 minus 3 is 1. And there's your answer. The other way to do it, which I didn't write down on the notes that are posted, but I'll show you here, is you can factor this. If you factor out the greatest common factor, then a to the fourth, that leaves me with 6 minus 4 is 2. Because I've taken out a to the fourth, and then minus, I've taken out a to the fourth, so minus 1 all over a cubed. Well, what is a cubed? A to the fourth divided by a cubed, because now, since this is a product, I can cancel. So a cubed's gone. 4 minus 3 is 1, so I have a times a squared minus 1, which is the same thing if I distribute the a, is a cubed minus a. So these answers are the same. So you can do that one of two ways. Most people probably would lean towards this way, but I just want to show you get the same answer if you factor. So just remember, before you cancel, you can't cancel this. You have to either cancel it with both places, since this is a difference, or you can write it as a product. Once you write it as the product, you can cancel those out. For the next part, you want to multiply or divide. So number 13, we have 9x to the fourth over 4y cubed times 10y over x squared. Okay, so when you're multiplying fractions, you multiply the numerators and you multiply the denominators, and then you can reduce. It's usually easier to reduce first. So if you multiplied 9 times 10, you get 90x to the fourth y in the numerator, and then 4x squared y cubed in the denominator, and you could reduce that, which is fine. I think it's easier to reduce before you multiply. So usually what I do is you can reduce straight up and down vertically or crossways, but you can't go horizontal, right? So we can do y and y cubed. 3 minus 1 is 2, so we'd have a y squared in the denominator. I can also reduce, I've got an x to the fourth and an x squared, so 4 minus 2 is 2. And then I can also reduce 4 and 10 because they both have a 2, so 10 divided by 2 is 5, and 4 divided by 2 is 2. That's all I can reduce for this, so now I can multiply. So I've got 9 times 5, which is 45. X squared, that's what I've got left in the numerator, divided by 2 times just 1, so 2, and I've got a y squared, and everything else is gone. Now, like I said, you'd get the same answer if you multiplied first, so you would have 90x to the fourth y 4, got everything crossed out here, make sure I get it right. Or I could have rewrote that and wrote x first, but anyways. So when you did this, you could simplify 90 divided by 4, you'd take out a 2, you'd get 45 and 2, which is what we have here. X squared goes away in the bottom because 4 minus 2 is 2. You'd have x squared in the top, and then the y makes it y squared on the bottom. So you'd still get the same answer if you multiplied first, but if you simplify first, you're not dealing with quite as big of numbers usually. So remember, simplify vertically or crosses, not horizontally. So number 15, we have 22m cubed into the fourth divided by 11m to the sixth n times 33 mn divided by 4 mn cubed. So again, for this one, so if you multiplied first without simplifying, you'd have 22 times 33 in the numerator, and then 11 times 4 in the denominator. And so those would be big numbers to try to reduce when you were done. So that's why I say it's easier to reduce first. So there's a couple of ways to reduce this. 22 divided by 11 is 2. That's one option. I ended up doing 33 and 11 to get 3 here. Because 4 and 22 both have a 2 in them, so I took out a 2 here, which is fine. You know, you can, there's different ways to go about doing it and ending up with the same answer. So then for your m's and n's, so like I said, you can do vertically or crossways. So this, for instance, over here, m over m, those just go away. So you can just cross them out and not worry about them. Over on this side, you've got m cubed over m to the 6th. So the m cubed goes away and the 6 becomes a 3. You have, well, probably the easiest thing to do, I didn't do it this way on the ones I wrote down because like I said, there's different ways to do it. But the easiest thing to do here is n and n are across from each other like this. They cancel, they go away. So you could just knock those out. And then n cubed and 4 minus 3 is a 1. So if you do it that way, it's fine. So we've got 11 times 3 left, which is 33. And then you have an n to the first left, and that's all you have left in the numerator. And in the denominator, we have a 2 times 1, which is just 2. And we have an m cubed left. And that, I got the same answer over here, but you see what I did over here instead was as I went this way. So 4 minus 1 is 3. And then on this side, n to the first over n cubed, 3 minus 1 is 2. So I still had n's left, and I had to simplify those to get to the same answer. But like I said, if you cross out this n with this n to begin with, you don't have to do that extra step. So several ways to get to the same answer depending on how you reduce it to start with. Okay, for number 17, you have 42x to the 5th over 16y to the 4th divided by 21x to the 4th over 8y cubed. So when you divide fractions, just like with numbers, division means you multiply by the reciprocal. So you want to, before you start reducing or anything, you want to just flip this, switch it to multiplication and flip this. So I don't reduce anything, even though 42 and 16 I could reduce something, but I don't do anything until I switch it to multiplication and flip, do the reciprocal of that one. So just like division with numbers, same thing. So keep the first one, switch to multiplication, and then flip the second one, do the reciprocal. So now I reduce. So once I do that, then I reduce. So what we can do is we have 16 and 8. So 8 goes into 16 2 times. So we have a 2 there. 21 and 42, also 21 goes into 42 2 times, so we have a 2 here. And then we have 2 divided by 2, so we can actually get rid of it. So we're just left with a 1 as your number, basically, because they all divided out of each other. I have an x to the 5th and an x to the 4th down here, so I've got 5 minus 4 is 1. I've got a y cubed and a y to the 4th here, so I've got y cubed's gone, 4 minus 3 is 1. So all I have left is x to the 1st, so x in the numerator, and y to the 1st, so y in the denominator. And remember on these, I don't think I mentioned it yet, but so y cubed and y to the 4th, if you do 3 minus 4, you're at -1, which puts your y back down. But anyways, wherever the bigger exponent is, so y to the 4th in the denominator, then it needs to stay in the denominator. Or like this one, x to the 5th is bigger than x to the 4th, so it stays in the numerator. So wherever your bigger exponent is where your variable is going to stay. Okay, so for number 19, I think I'll need another sheet for it. So for number 19, we have 3a plus 3b. And again, on these, you're just assuming that the denominators aren't 0, because we haven't wrote that down. A squared minus 4a minus 5 divided by 9a plus 9b over a squared minus 3a minus 10. Okay, so again, division, before you do anything, you want to switch it to multiplication and flip this. And now this one you're going to have to factor to be able to see if anything cancels. And if you are comfortable with it, you can factor on this step, like you could factor this, flip this over and factor it all at the same time, which is fine. Just make sure when you do that you flip this, because multiplication, when you're doing fractions, you want to, or when you're dividing fractions, you want to multiply by the reciprocal. So now I'm going to factor. So this one I have to factor out the greatest common factor of 3 is all I can do. So I've got 3 times a plus b. That's as far as that one will go. A squared minus 4a minus 5, it will factor into a minus 5 times a plus 1. And you can double check this using FOIL. A squared minus 3a minus 10 factors into a minus 5 times a plus 2. And then in this denominator here, 9a plus 9b, I can factor out the greatest common factor of 9, and that's all I can do. So now you can see what cancels. So because all of these are products, you can cancel them out. So like I've got an a minus 5 here and an a minus 5 there. Oh, switch back to my pink pen. Those cancel. I have an a plus b here and an a plus b here, so those cancel. I have a 3 and a 9, so 3 goes into 9 3 times. So what I'm left with is, in the numerator, I have an a plus 2 left. And in the denominator, I have a 3 times a plus 1 left. And again, you don't have to distribute this 3. When you get down to the answer, if it's wrote in factors, that's fine. You don't have to try to multiply anything back out. Just leave it alone. Okay, so that's multiplication and division. So just remember on those factor things, if they're not factored, you have to have products to be able to cancel. And when you're dividing, multiply by keep the first one, multiply by the reciprocal of the second one. So now we want to add or subtract. So just like with numbers, it's the same. Let me do number 22 here. A plus 6 over, you need a common denominator. Okay, so if it gives you the common denominator, that's good. So just like with numbers, if you have a common denominator, what do? You're, let me write one down here. Let's see, let's do 1/2 plus, I don't know, 3/2 is fine. So if you have a common denominator, you just add the numerators. So 1 over 2 plus 3 over 2, you got 1 plus 3 is 4 over 2, which is just 2, which is fine. So just like with numbers, if you have a common denominator, you just add the numerators and keep that denominator. So we've got a plus 3a, that gives us 4a. We've got 6 plus 5, that gives us 11, over our common denominator of a minus 1. Now when you get done with this, if the numerator can be factored, most usually they won't, but if they can be, you want to factor it just to see if something cancels. But like I said, normally they're probably not going to. So that's if you have a common denominator. Now, what if you do not have a common denominator? So like number 23, you have 2 over 3x plus 4 over 6x squared. So just like with numbers, so like if we wanted to do, let's We're going to write it out here. Let me do 2 over 3 plus 4 over 6, just to show you. So just like when we do numbers, we have a 3 and a 6, so we can turn the 3 into a 6 if we multiply the top and the bottom by 2. So then we would have 4, I could reduce this, but anyways, that's what it has here, so I'm just going to do it this way. 4 over 6 plus 4 over 6 is 8/6, and then it reduces as if I take out a 2, I can take out a 2 and get 4/3. So the same thing, you want to find your least common denominator. So I have a 3 and I have a 6. So when I have a 3 and a 6, my least common denominator is 6. And then I have an x and an x squared. So when I'm doing my common denominator, I'm always going to pick the bigger exponent. So I can't turn x squared into x, but I can turn x into x squared. So for this particular problem, you could also reduce 4/6 to, just like I said over here, which would make it okay. But anyways, we'll just do it this way. So what I want to do is, so if this is my least common denominator, then I've already got it here, so I need to turn this into it. So how do I do that? To turn 3 into 6, I multiply by 2, and to turn x into x squared, I multiply by an x. But whatever I do to the denominator, I have to also do to the numerator, because basically that means I'm multiplying by 1. So I have 2x times 2, which is 4x over 6x squared, plus 4 over 6x squared. Well, now that they have the same denominator, I can just add the numerators. So I have 4x plus 4 over 6x squared. And like I said, you want to see if you factor if anything cancels. In this case, you can factor out a 4. So I have 4 times x plus 1 over 6x squared. And then I can reduce the 4 and the 6 into 2/3. So I've got 2 times x plus 1 over 3x squared. So if you would have reduced here to start with, let's see, do it down here. You would get the same answer, 2 over 3x plus, if you reduce this to begin with, 4 over 6 is 2/3, so 2 over 3x squared. Well then, they both have a 3, so I don't have to worry about that. I just need to turn x into x squared by multiplying by x. So I would have 2x plus 2x over 3x squared plus 2 over 3x squared, which would give me 2x plus 2 over 3x squared. And I could factor out the 2 to still get the same answer. So you get the same answer either way. So for these, remember, like I said, you use the bigger exponent as your least common denominator. So just like you do with numbers, you just multiply, even if it's a variable, you just multiply to turn one of them into the other. For number 24, we have x plus 2 over x minus 5 plus x minus 1 over x plus 2. So again, for this one, your least common denominator is whatever you can turn both of these into. So if you would have had something like 1/3 plus 1/4, you can't turn 4 into 3 and you can't turn 3 into 4, but you can turn them both into 12. So you just multiply them together. So just the same thing. So your least common denominator is this times this. So x minus 5 times x plus 2. So on this side, I need the x plus 2. And if I do it to the bottom, I have to do it to the top. On this side, I need the x minus 5. And I just throw parentheses around it all so you don't forget to FOIL. So that gives me x plus 2 times x plus 2 plus, because now they have a common denominator, so plus x minus 1 times x minus 5 all over x plus 2 times x minus 5. Now here's where you can't just stop. You have to multiply. The denominator you don't have to multiply out. You leave it factored. The numerator you need to multiply out and combine like terms, and then you can see if it'll factor any further to be able to simplify it down. So we're going to FOIL this. So x times x is x squared. X times 2x is 2x plus 2x is 4x. And 2 times 2 is 4. Plus x times x is x squared. When I do the outer one, I've got minus 5x, inner minus x, so minus 6x, and negative 1 times negative 5 is plus 5. Over x plus 2, x minus 5. And then combine like terms, x squared plus x squared is 2x squared. 4x minus 6x is minus 2x, and 4 plus 5 is 9. Now here's where you need to check to see if this factors to know if you can reduce. Because if it factors into one of these, you could cancel it out. This one doesn't factor. The easiest way to check is to do that where you be doing like grouping method. 9 times 2 is 18. If you do factors of 18, you got 1 and 18, 2 and 9, 3 and 6. None of those will add up to 2. So you're done. And like I said, most of the time, it probably won't factor. Not for this class anyways. So number 25, you have 3a plus 5. I know this video is a little bit longer, so I'll try to do several of these. Most people don't like fractions. So again, you want your least common denominator. So they both have an a minus 1. You just need the a plus 4. So my least common denominator is a plus 4 times a minus 1. So this one is fine. I don't have to do anything to it. I just need it over here. So I'm going to multiply this one by the a plus 4. So I'm going to have 3a plus 5. Now here is a catch though. It's a minus this time, so you got to watch your signs. I'll multiply that out in just a second. All over my common denominator now. Okay, so when I multiply this out, I've got 3a plus 5 minus, and I'm going to just put a bracket so that you remember to distribute this negative. So 2a times a is 2a squared. 2a times 4 is 8a minus a. Minus 1 times 4 is negative 4. So this here is 7a, so let me write it like that. If you combine those all over my denominator of a plus 4 times a minus 1. So you have this minus sign. So the biggest mistake on these usually is that you write down minus 2a squared plus 8a minus, or plus 7a minus 4, and you only put the minus with the first term, but you have to switch all the signs because it's minus. So really what we want to do is it's plus, this is a negative, this is a negative, and that one's a positive. So you switch all those signs. So now we have negative 2a squared. 3a minus 7a is minus 4a. And 5 plus 4 is 9 over my denominator. And you can leave the answer right like that. Some people don't like having a negative right here with this leading this coefficient. They like to put the negative out in front, which I did here. You just change all the signs back on the numerator, switch them all, and put the negative out front. That's fine, but I'm fine if you leave this. And again, you want to make sure that this doesn't factor, so you can do the same thing. 2 times 9 is still 18, and factors of 18 haven't changed. So 1 and 18, 2 and 9, and 6 and 3, none of those add up to 4, so you're just finished. So it may be that instead of giving you a factored form when you're wanting to add or subtract, that they give you a polynomial, trinomial, binomial is what the factored form would be, but something more than a binomial, I guess I should say, like a quadratic that you have to factor. So you can follow the same idea, but you're not going to want to. But just so you know, a common denominator here is x squared minus 4 times x squared plus 9x plus 14. That is a common denominator. You could multiply this side by x squared minus 4, multiply this side by this trinomial, and simplify it that way. I wouldn't recommend it because it causes you to have to simplify and do a lot of multiplication that's not necessary. Sorry, my throat's dry. So what you really want to do is factor the denominators and then find the least common denominator. So if I factor this one, it factors into x plus 7 times x plus 2. And this one, it factored difference of squares, factors into x minus 2, x plus 2. So you see both of these, they already have the x plus 2, so I've already got that on both sides. So what my least common denominator is x plus 7, x minus 2, x plus 2. So all I need is on this side, I've got x plus 7, x plus 2, I just need x minus 2. This is a lot easier to multiply than trying to multiply by like a trinomial and stuff. On this side, I have x minus 2, x plus 2, I just need the x plus 7. So I'm going to have x minus 2 times x plus 3. Let me just write it out like this. Minus, again, it's minus, so be careful with your signs when you multiply this out. Over now my common denominator of, and it doesn't matter, this multiplication doesn't matter what order you write it in. It's, you can write it however you want to. I'm just going to write it like I wrote it there. So I've got, so again, I'm going to leave my denominator alone. I'm only going to multiply out my numerator and see if anything factors or simplifies. So x times x is x squared. I've got plus 3x minus 2x, so that's plus x. And then negative 2 times 3 is minus 6. Minus, again, I'm going to do a bracket, so you remember to distribute the negative. X times x is x squared. Plus 7x minus 5x is a plus 2x. And then negative 5 times 7 is negative 35. Over the denominator. So again, when you have minus this, it's minus this whole thing, so you've got to make sure you distribute that negative. If you want to write it again, you can, or I just usually put a plus and then put minus, minus, plus. So switch all those signs. So we've got x squared minus x squared, so those just go away. X minus 2x is a negative x. Negative 6 plus 35 is plus 29 over my denominator. And I'm done. Nothing simplifies any further. So we're finished. So just make sure that on those you factor first before you get your common denominator. Okay, for the next one we want to solve for solving equations. So if you want to solve rational equations, so we have 32 over x is equal to 16 over 3. So the first part of this was rational expressions, so now we'll do the rational equations. So you can cross multiply, that's fine, because this is a proportion basically. You can cross multiply. I'm going to keep with the least common denominator idea, and you want to clear fractions. So instead of cross multiplying, I'm going to do it this way. So my least common denominator here would be 3x. So I'm going to multiply this whole thing by 3x. So when I do 32 over x times 3x, what happens with the x's? They cancel. So I've just got 32 times 3, which is 96, which is the same thing if I cross multiply. But anyways, then if I do 16 over 3 times 3x, what happens with the 3's? They cancel. I'm left with 16x. So if I divide both sides by 16, I get x equals 6. And you're going to want to check all of these because, like before I was saying, we just assume that the denominator is not 0. If it's an equation, you can't just assume, because sometimes you might come up with an answer like for this one, x can't be 0. So 6 is not 0, so it should work. And it does. I've wrote down the checks on the notes. You can look at them. But you just want to make sure that for an equation that your answer does not violate a domain issue. because when we clear these fractions and we make it not have denominator, then sometimes you come up with an answer that doesn't work, because when you plug it back into the original, it gives you 0 in the denominator. Actually, we're going to do one like that in just a second. So number 29, we have 2 divided by y plus 2 plus 8 divided by y plus 2 is equal to 9 over y plus 3. Now on the notes, I didn't do it this way, but I'm going to do it this way here, just to show you that you do come up with the same answer. So for this one, these two both have the common denominator of y plus 2, which means I can just add them. So 2 plus 8 is 10 over y plus 2 is equal to 9 over y plus 3. So that's fine. On the notes that are written, I didn't do that. I just multiplied by the least common denominator. But anyway, so my least common denominator is not changed. It's still y plus 2 times y plus 3. I just simplified the left side first. And again, for this one, you can't have -2 or -3. As long as it's not -2 or -3, it should work. So I'm going to multiply by my common denominator. When I do 10 over y plus 2 times this, the y plus 2's cancel, and I'm left with 10 times y plus 3. When I do this one times this, my y plus 3's cancel, and I'm left with 9 times y plus 2. So distribute, I've got 10y plus 30 is equal to 9y plus 18. Solve, subtract 9, I get y is equal to subtract 30. 18 minus 30 is -12. Well, that's not -2 or -3, so it should work. And it does. I didn't actually write that one all the way down on there, but if you plug it in, it does work. I put check and put a check mark. I just didn't write out the numbers. Okay, for number 30, you have 4x over x plus 2 minus x over x plus 1 is equal to 3x squared plus 4x plus 4 over x squared plus 3x plus 2. So again, if you don't factor this beforehand, you don't know what's the least common denominator. So what you want to do is factor this first. So these are already simplified. So we're just going to keep them alone, leave them alone, keep them the same. And we're going to factor this one. X squared plus 3x plus 2 factors into x plus 2 times x plus 1, which is convenient since that's what we have over here in pieces. So my least common denominator is x plus 2 times x plus 1. And again, for this one, x can't be -2 or -1. Set both of those equal to 0 and solve. So I'm going to multiply this whole thing by x plus 2 times x plus 1. When I multiply this by this, my x plus 2's canceled. I'm left with 4x times x plus 1. Minus x, when I multiply this by this, the x plus 1's cancel. I'm left with minus x times x plus 2 is equal to, this whole denominator cancels, so I just have the numerator left. So now I'm going to distribute and combine like terms. So I got 4x squared plus 4x minus x squared minus 2x. Make sure to distribute the negative. And then when I subtract over, I'm going to have 4x squared minus 3x squared is x squared. 4x minus 4x goes away, and oh, whoops, I forgot to do this first, I'm sorry. 4x squared minus x squared is 3x squared. I skipped a step. 4x minus 2x, let me go in order. 4x minus 2x is 2x. Okay, now let me try that again. Got ahead of myself. Okay, now when I subtract the 3x squared over, they go away. When I bring 4x over, 2x minus 4x is -2x is equal to 4. So x is -2. But if I go back, I said x can't be -2 because if I plug in a -2 into the original, this makes a 0 in the denominator, which can't happen. So this is just no solution. So that's why you always want to double check these. Make sure that it doesn't cause a 0 in the denominator. So, for applications, we're almost done with this section, so it's a little bit longer. So for an application, instead of me writing all this, I'm going to show it to you on this. When the same number is added to both the numerator and the denominator of 5/8, the result is 3/4. What is the number? So our n is the number, and we're going to do the same number added to both the numerator and the denominator. So, of 5/8. So we've got 5 plus n over 8 plus n is equal to 3/4. So once you translate that into your math, then you just do it the same way. So my least common denominator are these multiplied together, 4 times 8 plus n. And n can't be -8. So as long as I come up with an answer other than -8, it should work. So I'm going to multiply this whole thing by 4 times 8 plus n. So when I do this one times this, the 8 plus n's cancel, and I'm left with 4 times 5 plus n is equal to this times this. The 4's canceled. I'm left with 3 times 8 plus n. So I have 20 plus 4n. When I distribute, it's equal to 24 plus 3n. Subtract 3n, I get n. Subtract 20, I get 4. N is 4. And it does work. It's not -8, so it should work. And it does. I wrote it down on the other paper. So just check these. Number 33. So again, instead of writing it all, you have, let me just tell you this. So one pop can fill, let's say it's a pool, I can't remember what it was, but we'll say it's a pool, fill it in 8 hours, and another pop can fill the pool in 5 hours. How long does it take them together? So just like, this is the same idea as if you're mowing a lawn, like you can take, it takes you 2 hours, it takes somebody else 3 hours, how long can you do it together? So it should take you less time together. So the easiest thing to do is to make a table, because when you're working together, the portion done by, for this one, we've got 2 pops, pop 1, plus the portion done by pop 2, what does that give you? Like I said, if they're filling up a swimming pool, that gives us 1 total full swimming pool filled up. So they're done, 1 total job. So I make a table for this, and you don't have to, but I think some people can see it a little better when they see it in a table. So what you want to do is do, how long does it take them alone? The part that they can do in 1 hour. The time it takes together, which is your variable in this case, because that's what we're looking for. And the part done by each in terms of that variable. So, how long does it take pop 1 alone? I've just told you it was 8 hours. How long does it take pop 2? That's 5 hours. So how much can pop 1 get done in an hour? Well, if it takes him a total of 8 hours, then in 1 hour, he would have 1/8 of it done. Or he, I don't know, it could be a she, I guess. But anyways. Pop 2, how much can pop 2 have done in an hour? Well, if it takes total 5 hours, then in 1 hour, pop 2 would have 1/5 of the work done. So together, they're going to take the same amount of time because they're going to both be pumping, filling this pool up. So they're going to both be working until it's done. So they're both going to take T amount of time together. So the part by each would be pop 1 can do T times 1 over 8, so T over 8. And pop 2 would be T times 1 over 5, so T over 5. So, this is where you get your equation to solve. So if you take the part done by pop 1 plus the part done by pop 2, that gives me 1 total job. Solve this. My least common denominator here is 40. Now you can add these if you wanted, but oops, I forgot to switch to pink. That's okay. multiply both sides by 4, multiply everything by 40, t over 8 times 40, the 40 and 8 reduced to 5. T over 5 times 40, the 5 and 40 reduced to 8. I do it this way because you want to just clear the fractions. If you get rid of fractions, the better. Then you don't have to worry about them. So 8 plus 5 is 13, t is 40. So t is 40 over 13, which is 13 and 1/13. So together, 3 and 1/13. I had 13 in my head. So together, they would take 3 and 1/13 hours. So it wouldn't take them as long together as it would individually, which makes sense. Should be able to work faster together. So for work problems, a lot of people get confused about how to come up with this. And like I said, I do the chart just because, I don't know, I feel like I can see it better that way. So for the last couple of things here, we want to finish up with complex fractions. So you want to simplify these complex fractions, which are fractions within a fraction. Some people don't like fractions, and then you'd give them fractions within fractions, and they really go berserk. Should have put a mint in my mouth. But anyways, we have a plus 1 over x over a minus 1 over x. So what you want to do, though, is you want to write it like this. You want a fraction over a fraction. You don't want a plus and minus thing. So we're going to get the common denominator in the numerator and the common denominator in the denominator and write it as a fraction over a fraction. So in this case, the common denominator here is x, so I'm going to multiply by x over x. Same thing down here. Oops, x over x, not a. So we have ax plus 1 over x. That's if I simplify and I add together the numerator, over ax minus 1 over x. If I get the common denominator and add and combine them in the numerator and the denominator. Now then all it is this means division. So anytime you have division, what do? You keep the first one, so we're going to keep the top one. Change from division to multiplication, and I'm going to flip the bottom one, do the reciprocal of it. So then it don't look so bad. Now my x's cancel, and I'm left with ax plus 1 over ax minus 1, and I'm done. So complex fraction isn't terrible because it's just like we were doing with the divisions. It's a fraction within a fraction, so like I said, write them both as one single fraction first, so you have to add or subtract or whatever. Write them as one single fraction, then you just follow the division rules. Keep the first one, switch to multiplication, and flip the bottom. So for one more like this, we have 1 over x squared minus 1 over y squared all over 1 over x plus 1 over y. So again, I want it to be a fraction over a fraction. So in this numerator, I need x squared and y squared. That's my denominator. So on this side, I need a y squared. On this side, I need x squared. So my numerator is y squared minus x squared over my common denominator of x squared, y squared. All over, if I do my denominator, it's xy, so I need a y on this side and an x on this side. So y plus x over xy or yx, however you want to write it. Now, again, this is division, so I'm going to keep my numerator. I'm going to go ahead and factor this too. Y squared minus x squared is a difference of squares, so that's y minus x times y plus x over x squared y squared times, I'm going to flip this one, so I've got xy over y plus x. So using difference of squares, these are the same, so I kept the numerator and then I've switched to multiplication and flipped the denominator. Now I can simplify. Y plus x cancels. X and 2 minus 1, x squared, so x squared down here, 2 minus 1 is 1. y and y squared. I didn't mean to cross off y, that's okay. Y squared, 2 minus 1 is 1, so I've got y minus x over x, y. And I'm done. And again, on these, you can just assume that the denominator is not 0. So for complex fractions, just like division, write it as a fraction over a fraction, keep the numerator, switch to multiplication, flip the denominator, and simplify. So for our last thing, we want to divide, and sometimes you have to do long division. So for this one, we did one similar to it to start with. I didn't call it division, I just said reduce. Same idea. So this one, if you have one like this, you don't have to do long division because I can split this up into pieces. So I can do this over this, this over this, this over this, and this over this. So if I split it into pieces, then I can divide. So a squared divided by a is a, and if you want to cross out, you can. B squared divided by b is b. 2 minus 1 on both of those. Plus, the 4 stays because there's no number down here to do anything with. So a squared divided by a is a. B divided by b, well, those are gone. Plus 6 stays. The a's are gone. B squared divided by b is b. Minus 10 stays. You got a gone, b gone. So there, you're done. So that's dividing, which is, you know, you're just reducing. You're just putting this with each piece. But if you cannot do it that way, if you need to do long division, like in number 41. 41, we have 4x to the 4th minus 4x cubed plus 2x squared minus 2x minus 1, all divided by x minus 1. So I can't really do each piece divided by x minus 1, so that doesn't work. So what I want to do is do long division. And just as a note, if you are missing any exponents, so in this one you're not, they start at 4, 3, 2, 1, 0. That's fine. If you're missing any, you want to plug them in with zeros just to make your life easier, because when you multiply, sometimes they pop up. Like if there's no cube, you might still get a cube when you multiply. So anyways, so how can I turn x into 4x to the 4th? I'd multiply it by 4x cubed. And if I do that, 4x cubed just works like just regular long division. 4x cubed times x is 4x to the 4th. 4x cubed times negative 1 is minus 4x cubed. Subtract, just like in regular long division. 4x to the 4th minus 4x to the 4th cancels. Negative 4x cubed minus negative 4x cubed. So this is minus a negative, which if you want, we can write it this way so you don't forget. These also cancel. So then what do? I bring this down. And since I don't have anything here, I'm going to bring this one down. How do I get an x to be a 2x squared? Well, multiply it by 2x. 2x times x is 2x squared. 2x times negative 1 is minus 2x. Again, you're going to subtract. And again, if you want to write it as a plus and switch these signs, that's fine. Just don't forget, just you're subtracting the whole thing. 2x squared minus 2x squared goes away. Negative 2x plus 2x goes away. So this is again 0. So I'm going to bring down my last thing, which is negative 1. I can't turn x into negative 1, so that's my remainder. So I'm going to write the answer as 4x cubed plus 2x. And then you put your remainder, so minus 1 over your divisor, x minus 1. And you're finished with that. And so the last one we're going to do, I can't remember, I don't think there's any of these on your homework, but I just want to introduce the idea for long division for these. So if you're factoring, I think I mentioned it in the notes, but we didn't really do any on the homework. But if you're factoring, there are formulas for the sum and difference of cubes. So if you look at this, this is a sum of cubes, if you know what that is. But anyways, so if we want to do this by long division, we've got x plus y into x cubed plus y cubed, but see, you're missing some stuff. So I'm going to just write down x cubed for just a second so that you can see what I was talking about. So I'll stick plus y cubed out here. But anyways, to turn x into x cubed, what do? I have to do an x squared. What does that give me? X squared times x is x cubed. And x squared times y is x squared y. So you see that's not here. So that's why I was saying if you're missing exponents, you want to do them with zeros. So we've got a 0x squared y, and then you should have a 0xy squared as well before you get to y cubed. So if you do that with zeros, it helps you line up exponents and stuff. So I'm going to subtract, or again, if you want to write plus, negative, negative. The x cubes cancel, and the 0 minus x squared y squared is minus x squared y squared. And then I want to bring down this 0, which looks funny, but that's okay. So how do I turn x into negative x squared y? I do a negative x, y. Negative xy times x is negative x squared y. Negative xy times y is negative xy squared. So see how that 0 is helpful. I'm going to subtract these. So again, you're going plus, plus, plus. It makes them all positive. So these are gone. 0 plus 1 is 1. So I've got xy squared. And I bring down my y cubed. How do I turn x into xy squared? I just multiply it by y squared. Y squared times x is xy squared. Y squared times y is y cubed. When I subtract, it's minus everything. They all cancel. My remainder is 0. So if you knew the sum of cubes formula there, you would know that that's what the answers you're supposed to get anyways. So that's just for long division. Like I said, the zeros are helpful. So on your homework, if you have any questions or if you want any other problems done, I know this video is a little bit longer, but rational expressions usually takes a little bit longer anyway. So if you have any further questions, please just let me know.